go. All right, so we got our 25 questions that we're going to go through. Okay, so again, the first ones are all about complementary angles, supplementary angles. What do we remember about complementary?
Complementary equals up to 90.
Add to 90. So two angles add to 90 degrees. Or if we're in radians, what would that be? Pi over 2. Good. And then what does supplementary mean? You bet. So, or pi. Two angles that add to 180 degrees. Or as you said in radians is pi. So, our angle that they give up here is 4 pi over 11. So is that radians or is that degrees? Radians. So all we have to do is just follow like what you guys told me to do. So we're going to take, for complementary, 4 pi. And how do I get the other angle? I'm going to subtract what? I'm going to add. Not pi over 2. Oh, wait, sorry. I'm thinking of 2 pi. Yes, I'm joking. It's the lunch I had that's talking. Yes, we're going to subtract pi over 2. So in other words, it's just like what we were talking about a couple minutes ago. It's like taking fractions and subtracting themselves. Leave pi alone, and you're going to take basically 1/2 minus 4/11. So you go to your handy-dandy calculator, you let it do all its work, and we get what over what? 3 pi over 22. Okay. How do we do the next one? How do I get the other angle? You got it, Jasmanian devil. Subtract pi from 4 pi over 11z's. And so you're just going to calculator. 1 minus 4/11 gives us 7 pi over 11. And there you go. Cool beans? Yes. Good. I'm glad you agree. So let's jump over to number 2. So this one says sketch the angle A equals -60 degrees in standard position and draw an arrow representing the correct amount of rotation. So we don't have on here the multiple choice like you have, but remember that it's not hard to talk about standard position. What do you remember about standard position? Which side of the x-axis? Positive side of the x-axis. So we have our initial ray right here on the positive side of the x-axis, and then we have to sketch -60 degrees. So negative degrees, do we go clockwise or counterclockwise? We go clockwise, because for positive angles, we go counterclockwise. So we need to go 60 degrees clockwise. About said counter. So 60 degrees looks about like that. Close enough, and it turned this direction. So that would be -60 degrees, roughly. And so that would be picture C on your guys' little charts. So then again, it's asking us a couple of other information. They want to know what is the least positive coterminal angle. So how do I get that? Not add 300, add 360 to it. Yeah, we got to turn that and get it an angle between 0 and 360 to be the least positive. So you add that 360, and what do we get? 300. So there we go. 300 degrees. There's the least positive. Now, it says give us the greatest negative. There you go. Yeah, technically the directions are horrible on this, And the greatest negative coterminal angle is actually given to you already. It is the negative 60 degrees. But what they really want us to do is give us another negative coterminal angle. Not the greatest, but another one. So technically this word right here is poo-poo. So really all they want is a negative coterminal angle. Not conterminal angle, but it's cool. So we can do that too. So we take negative 60 degrees, and what are we going to do to it? Subtract 360. And what do we get? 420. Negative 420 degrees. Okay? And then last but not least, it says what quadrant of the terminal side. So in other words, what quadrant are we in? Quadrant 4Z's. There you go. Okay. So number 3, moving on. And if you got any questions about these as we move along, just ask. So A-okay. Even though we are recording, it doesn't really matter because they probably have the same questions on the other side. So it says convert the following to radians, or from radians to degrees. So how do I take 5 pi over 6 and convert it into degrees? There you go. Times it by 180 over pi. You got it. So what's going to happen to the pi's? They cancel. So really all you're doing is you're taking 5/6 times 180. And what do you get? 150 degrees. Perfect. All right. Let's jump over to question number 4. Question number 4 says, how long is an arc intercepted by a central angle of 135 degrees and a radius of 16.47 inches? So, what is the formula to find arc length?
S equals radians times the delta.
Not radians. Radius times the theta. Radius times the theta. So the S is the arc length. What was the R again? Radius. And the theta is our angle, right? But it has to be in radians. Good, Jasmanian Devil. Theta must be in radians. So that means the first thing we have to do is take that 135 degrees and convert it. How do we convert 135 degrees to radians? Multiply it by pi over 180. Perfect. So in other words, what you're doing is you're basically going to leave pi in the numerator, and you're going to reduce the fraction of 135 over 180. And what does that fraction reduce to? So we're looking at a radians degree of 3 pi over 4. That's our theta. So now we can take and we can plug into our little equation right here, which I'm going to move right down there. And we can figure everything out. So what was our radius? 16.47. Okay, and we're going to multiply that by 3 pi over 4. Now, in this one, when you read that fine print, it wants you to round to 2 decimal places, which means that they actually want you to use a number for pi. Okay, so that means use that pi button on the calculator. Don't use 3.14. It is a rounded digit. Okay, so actually use a real number for pi. You know, 3.1415, blah, 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 blah. Okay, that's why they gave you the pi button on there. So you're basically just taking 16.47 times 3/4 times pi. And you're going to get an answer, and you're going to round it to 2 decimal places, which gives us what? 38.81. And they provide us the label for us, but it is inches, if you were dying to know. Okay. question number 5. So this is getting us into the unit circle. So just kind of give you a quick reminder, questions 1 through 4, they all came from 9.1. So question 5 through the next couple, I'll tell you when it gets done, but now we're in section 9.2. So this is all about the unit circle. So it says evaluate the following trig functions based on the information given to you. So they're showing you where the 5/13, comma 12/13 point is at. They're giving you a nice little picture. All you have to do is remember we're on the unit circle and remember our little formulas. What was the formula for sine on the unit circle? It's just whatever y is. What was the formula for cosine? It's whatever x is. And what was the formula for tangent? And there you go. Again, this is only true on the unit circle. Okay? So, we know our point. So what was the y value from the point? 12/13. So there's your sine value, which is 12/13. What was the x value from the point? So there is your cosine value, 5/13. And then last but not least, tangent. So we're going to take our y value and divide it by our x value. What is our y value again? And now remember, we talked about this in class. We don't really divide by fractions. What do? Multiply by the reciprocal. So what's really going on here is you're looking at 12/13 times 13/5. And what's going to happen to your 13s? Yes, along with the screencast-o-matic sign. 13s cancel, so what are you left with? 12/5. You're geniuses. Perfect. All right. Question number 6. Same question again, except this time we have all 6 trig functions. All 6 trig functions. Now, they're telling us that the geometric function that we're looking for is 4 pi. So we need to take this and do what to it first? We're going to subtract 2 pi from it. Why? There you go. We want to get this down to its least positive coterminal angle. So that way we can figure out which quadrantal angle it is. So you just take 4 pi, subtract 2 pi from it, and that gives us 2 pi. Where if you subtracted 2 pi again from it, that would give you 0. And you could either work it from the 2 pi or the 0. So which point up here represents the 2 pi or the 0? 1, 0, right here. This guy pulls double duty. It's 0 and 2 pi at the same time. So you're working with the point 1, 0. This is how we're going to get all of our trig functions. So, going back to what we know, we're on the unit circle. What's the formula for sine? It's y. What's the formula for cosine? What's the formula for tangent? Y over x. So let's get some quick answers. So what is the answer for sine then? It's going to be 0 because it's your y value. What is the answer for cosine? That's your 1. What is the answer for tangent? It's going to be 0 because you'll have 0 divided by 1, and when you go to your calculator, we can actually do that. So there's your first 3 answers. Now to get the other ones, cotangent, secant, and cosecant, we just use what? The reciprocals. Who is the reciprocal of sine? Cosecant. So if I take 0 and do the reciprocal of it, what do I get? Undefined, because it puts that 0 in the denominator, and that's bad news bears. So cosecant is undefined. All right. Who is the reciprocal of cosine? Secant. So what do we get for secant? Just 1. Because you take 1 and you put it on the bottom. Remember, there's another number 1 underneath it, so 1 over 1 is still 1. And then cotangent is undefined because it is the reciprocal of tangent. And again, you take tangent, you put the 0 on the denominator, bad news bears, it has to be undefined. There you go. All right, question number 7. So, they say given this angle, alpha, we know that sine alpha is negative 15 over 17, and cosine alpha is 8 over 17. They want us to find the other trig functions. We are still on the unit circle. Okay? Still on that unit circle. So, with that being said, how do we know sine is made? It's just y, right? How do you know that cosine is made? It's just x. So you can use those facts to your advantage to help get everybody else. But the other thing you know, that if you know sine, you know cosine, you really do know a lot of these other ones because they're reciprocals, right? Or the other fact, yes, tangent is y over x, but we also know tangent has another identity. How else can tangent be made? Not a reciprocal. It's similar to y over x, but it's not y and x that are used. There's something else that's in place of those. Remember that tangent is also sine over cosine. So even though they didn't tell us that we're on a unit circle, we are on the unit circle. We don't have to use that fact. Okay? We don't really need to know that we're on the unit circle, but we are. Don't get me wrong, we are. But we can just use the fact that we know that tangent, another way of getting tangent is just put the sine over the cosine. So if I did sine over cosine, what goes on top? What's my sine? Negative 15 over 17 divided by 8 over 17. And we just talked about this a moment ago, that we will multiply by the reciprocal. And what is tangent? Negative 15/8. So now that we have the 3 basic trig functions, sine, cosine, and tangent, everybody else is just reciprocals. So again, I mean, you can think about it in terms of the x and the y, but you can also just think about it in terms of the trig functions they are. They're reciprocals of each other, and tangent is made up of sine over cosine. So cosecant, what's that answer going to be? You got it, because it is the reciprocal of sine. And so when you take sine and flip it upside down, you get 17 over 15, and you keep it negative. What is secant going to be? 17 over 8, and cotangent. Negative 8 over 15. Perfect. Any questions on that? Anthony, you all right?
Yeah.
You sure?
Yeah, just writing down the keys.
Okay, no worries. All right, so jumping into number 8. All right, so question 5, 6, and 7, that was from 9.2. 5, 6, and 7 was 9.2. Now starting at question number 8, we're jumping into 9.3, because now we're getting into graphing. So remember 9.3 was all about just graphing sine and cosines and all that stuff. So remember when we were doing these, we talked about these equations in general, that they look like this. Your trig function, whatever it might be. Dang it. Untitled page. We don't really care about the untitled page. We are on number 8. So There we go. Oh, D. Yes. My line didn't get there. Let's fix that. So it doesn't look so bougie. Shh. All right. So that's basically what we're dealing with. And remember that the A, B, C's, and D's, they all controlled something. Okay? So this guy, it is a multiple choice question for you. But all we have to do, we can fill in this information even though it's not multiple choice and figure out which one it is. So the first thing is the amplitude. Who controls amplitude? A, B, C, or D? A. So do I have an A value up here? Absolutely. It is 4. So that means the amplitude is 4. So that means that would be how high our waves go. So our waves would go up to a positive 4 and down to a negative 4. Okay? The period. How do we figure that out? 2 pi over b. Cool. So we're going to take 2 pi divided by b. That's our formula. And for sine and cosine, the period is 2 pi. We'll get to the other 4 functions soon enough, once we hit 9.4. So the period on this guy, what is our b value? It is 6. So you're going to take 2 pi divided by 6, and what do we get? Pi over what? 3. So our period now is pi thirds. Okay? Phase shift. Who controls the phase shift? That's your D. And phase shift just means left and right. How far are we moving left and right? Who's our D value? Yes, there you go. Because this guy right here, technically the 6 is our B, but you guys got to remember that this should look just like how it looks over here, where you have a B and then a parenthesis with your X minus the D. So remember in class I told you that whenever you have it like here where you don't see that extra set of parentheses in there, that you need to pull a GCF out. You need to GCF this bad boy. So we're going to pull that 6 out, which is our true B. But if we pull that 6 out, that means everybody in there is getting divided by 6. So 6x divided by 6 gives us x. What's negative 2 divided by 6?
I got
Negative 1/3 it is. Now you know what your true D value is. So we do have a phase shift, and what is the phase shift? A positive 1/3. That's right, because the negative, this guy right there, is just a subtraction sign that is a part of the original function. So we need an answer that has an amplitude of 4, a period of pi thirds, and a phase shift of 1/3, and that answer ends up being C. There you go. Okay? All right. So number 9. Still in 9.3 because it's all about sine this time. So this one, it actually wants you to make a graph. Okay? Well, actually, it has a graph down below of multiple choice. We'll get to that, even though on here they only give us a blank graph. That's fine. We'll work it. So the first thing, though, that they want you to talk to us about is the amplitude and the period. So we just kind of talked about this. Again, what is your value for the amplitude up here? There's a 1. Yeah, absolutely. It's the number that's in front of sine, and the number that is directly in front of sine is 1, so that means the amplitude is 1. That means our graph will go up to a positive 1 and down to a negative 1. That's how high our waves are going to be. Okay? Period. We just talked about how to find the period. How do we do that? 2 pi over b. So in this case, it would be 8 pi, because we'll take 2 pi divided by the 1/4. We don't have to worry about pulling out any GCF in this one, because there's no adding or subtracting going on by the x. Okay, there's no parenthesis there. So when you take 2 pi divided by 1/4, that gives you 8 pi. So we know that instead of going 2 pi, we're going to go 8 pi. Are we moving up or down? No. Do we got a phase shift? No. So this is basically just a sine graph that we made longer. A sine graph that we made longer. So let's just talk about our sine graph, and let's do this. So we know that it has to start where? Where do sine? It's got to start at the origin, right? It's going to start right here. Okay? Let's call this guy 1. This guy right here, -1. Okay? So then it goes out to our first mark. Well, actually, it will go out to our end mark, which is what? So my end mark is right there. That's got to be 8 pi. Okay? Do you know where it ends for sine? Does it end on the amplitude or on the axis? It's going to end on the axis. Okay? Now, do you remember how to find the middle of this guy? Yeah. Add the two endpoints and divide by 2, right? Because you're finding a midpoint. So 0 plus 8 pi is 8 pi. 8 pi divided by 2 is 4 pi. So we know this guy right there is 4 pi. Okay. We'll deal with our dots here in a second. Let's get everybody else. So now, how do I figure out what this middle line right there?
When you use the formula of 0.
Yeah. So you're basically finding the midpoint between 0 and 4 pi. So just add those together. 0 plus 4 pi is 4 pi. 4 pi divided by 2? 2 pi. How would I find this last midpoint? There you go. 4 pi plus 8 pi is 12 pi. Divided by 2, 6 pi. So now we can just do the rest of our picture. So you already told me it starts at the origin. Where does it go from there? Goes up to my amplitude. Then where does it go? Down to 4 pi on the line. Then where? Down to -1. And then you already gave me the last point. So there's what the graph looks like. So when you go down below and you look at your pictures, which one is it going to be?
Looks more like A.
Looks more like A, and A is correct. Okay? All right, number 10. So again, we're going to make another graph. Okay, so this is the one that you'll actually be filling in the control box for. So we'll talk about that control box, and then I'll show you what the graph would look like. So first things first, does our amplitude, because you have a control for amplitude, does our amplitude change? Yes. What's the amplitude? 4. Good. So sometimes it's a slide, sometimes you just put in the number. So you either slide it to 4 or you slide it, or you type in the number 4. Okay, then right across from that, right next to this guy, it asks about the period. So we've been talking about the period for a little bit. How do we find the period? 2 pi over b. Good.
That's the one we found for cosine.
Say it again.
That's the one we found for cosine.
That's the one we find for cosine, because cosine has a period of 2 pi. Okay. So what is our b value? B is 1, and the period is definitely 2 pi. Yeah, because there's a number right here in front of the x. Even though there aren't parentheses there, they really do exist, because the GCF is 1. When you pull a GCF of 1 out, it doesn't change anything. So you still have 2 pi over 1, which is the 2 pi that you said was going to happen. So again, in here, I know it's the board. It messes up sometimes. So when you go into the box, you either slide it to 2 pi or you'll type in the 2 pi. Okay? So then from there, down below it gives us 2 other boxes. One of them says vertical shift. And there is none because there's no D. There's no number in front of the 4. Sorry, C. There's no C. That too. There's no C value. So there is no vertical shift. There's no moving up and down. So we know for sure that our graph should go up to a +4 and down to a -4 this time. We know that for sure. Okay, and then it will ask, what is the phase shift? And what did you say again? Negative pi over 2. And in this one, when you have to put in pi, because there's no button for it, what do you push? Pi. So you'd push the negative button, then you would type in pi, which will turn it into the pi symbol, and then divide it by 2. Perfect. And it is negative because this symbol is not from the original information, because remember in here, it is x minus d. So in order for that to become a positive, it would have had to been a negative d that you plugged in, which is why it's a negative pi over 2. And then right below that, there's only 2 other questions. They're little boxes, and you check them or not. And it says reflect x-axis, reflect y-axis. So who controls the reflection over the x-axis? The A does. And only if the A is what? Negative. Is my A up here negative? No. The 4 is positive. So there's no reflection over the x-axis. So do not check the box. Who controls reflection over the y-axis? B controls that. And again, when B is what will it reflect? Negative. But remember, in our homework and things like that, you didn't really have to worry about reflecting over the y-axis. It was mostly, do we reflect over the x? But again, just for our reference, B is the one that controls reflecting over the y-axis. And again, just like the other one, only if it's negative will it reflect. So do not check these boxes. So this is what would get filled in, and it would generate your graph, and that's what it wants. But unfortunately, this guy is not filled in for us. There's no control box, so I'm going to show you what it looks like. So we're basically just taking the cosine graph. We haven't changed its period. We're going to make it a little bit taller, and we're just going to shift it a half a pi towards the left side. Okay? So instead of ending at 2 pi, we'll end at 3 pi halves. So we'll begin over here at pi halves. Negative, you'll have your 0, you'll have your positive pi halves, you'll have your pi, you'll have your 3 pi halves. So that there is a distance of 2 pi. And then we know that our top value goes up to 4, and our bottom value will go down to the negative 4. Now the question we have to answer to ourselves, where does cosine start? Well, normally it's on the y-axis, but we've shifted. So, in other words, does it start on the x-axis or does it start at the amplitude? It starts at the amplitude. Which one, the positive or the negative?
The positive one?
It starts at the positive. Cosine starts up at the top, at the positive, and then where is it going to go now? Down to the origin. Then where? Down to negative 4. Then where? Up to pi, the x-axis, and then where? And at the positive 4 amplitude. So this is what the cosine graph looks like. Okay? All right. Again, you wouldn't be drawing that by hand. Once you put all that information into the control panel, it kicks out the picture for you. You just got to make sure that you fill in the correct information. All right. So question number 11 starts 9-4. So we just did question 8, 9, and 10. And all of that was from 9-3. So now question 11. And I'll tell you question 12. 11 and 12 are all from 9-4. So these are the last of the graphing. All right. So again, 11 and 12, they are multiple choice questions with the graphs. So if we know a little bit about the graph, and what the equation is doing, it's easy to pick out the graph. So first things first, with this guy, we're dealing with cosecant. Who did I tell you cosecant is just like? It's just like the sine graph. All we do is we take kind of like the reciprocal of the little of the waves, the tops and bottoms, and we make them into U's and arches. Okay? So this guy is going to look like a sine graph. So let's start talking about a couple of things. We know that these things are going to look like U's and arches in the end. So we can narrow down some of our pictures. Which two can we get rid of right now? A and D can go away because A is either a tangent or a cotangent graph, and D is either a sine or cosine graph. Remember, our graph has to look like U's and arches, like what I showed you up there. All right, a couple things now. What does this -5 mean for us? It's going to reflect over the x-axis. Good. So we know that we will reflect over the x-axis. And what does the 5 also mean? We have an amplitude of 5. That means we need to go up to a +5 and down to a -5. All right. So if we look at what the sine graph of this is, if we kind of think about it, because I don't have my graphs to draw on like what you guys got. Sine starts at the origin, right? And then normally sine goes where? Up to the amplitude. But we reflected. So where's it going to go this time? It would go down to the negative. Because it's upside down. Normally sine goes up first, but because we are reflecting over the x-axis, it goes down first. So this is what happens at pi/2. Pi, 3 pi halves, 2 pi, because we didn't change the period at all. So where do I go after I'm down here? Up to pi. Then where do I go? Up to 5. And then where do I go? Remember that anybody along the x-axis is really what we call asymptotes. So these are those vertical lines. You may or may not see them in your picture. And then at these dots are where we put our U's and our arches. So that guy is a U. This guy is an arch. So which picture matches that one? Say it again. B. There you go. Yeah, C also goes through the y-axis, which is telling us that is the, and it starts down, so that is the inverse of, or sorry, not the inverse. That is actually -5 secant x. That's what the picture of C really is. So again, just knowing a little bit about what's going on kind of helps you out. Okay, number 12. So again, we know this is cotangent. What do we know about cotangents? It kind of looks like tangent. They look like cubic graphs, right? All right, so let's start breaking this thing down. So cotangent. What does this do to the cotangent? Reflects over the x-axis. We've changed it. We're going to reflect over the x-axis. So the cotangent graph now looks like a what? It looks like a tangent graph. Do you remember how tangent graphs go? Does it start up or down first? Starts down first and travels up like that. That's the tangent graph. So right now you can narrow down your picture to who? A, B, and C. You got it. So right now it's one of those three. Okay? Because it has been reflected. All right. So now the next question is, what's the 2 do? A vertical shift. That means it needs to have looked like it's gone up 2. So again, we can narrow things down. B and C. Now we got a 50-50 shot of being right. Just from those two things. Now the rest of this comes from remembering what cotangent where it originally starts. Where does cotangent originally start? Does it go through the y-axis or is it beside the y-axis? It's beside it. Cotangent, this guy that we basically are looking at, means that we got our asymptotes right here. That really should have been dotted. Let me do that. Cotangent starts beside it and is only a period of pi. And because we know that we have shifted up, basically what's happened, normally cotangent would start right here and come up through there, like that. Or sorry, normally cotangent would start there and look like this. But remember, it's been reflected and moved up, right? So this is what the original cotangent looks like. So when we reflect it, it was like what I just drew a second ago, this guy. But again, remember that it's been moved up too. So we'll just grab this. I thought I had the selector 2 on. And you just basically move it up too. So which picture looks like that guy? C. That one's it. Because your B is actually the tangent graph. Because it goes through the y-axis. Okay?
How would you know where it lands at 2?
How would I know? Because remember that we went up 2. So if I was originally on the x-axis, if I go up 2, if I was originally on the x-axis and I go up 2, my dot has to be right there, right? Okay.
I'm kind of seeing it as more like it's the only point where it intercepts.
Yes, pretty much. Okay? No need to throw anything around, Jasmine. All right. Quit stressing. So, starting on number 13, this is where we start the 9.5. This is where it's important to remember that we are not on the unit circle anymore. So this is where we start caring about the radius and figuring it out. Okay? And remember, how did I tell you how to figure out the radius? What's our common formula? There you go. Pythagorean theorem. It's a squared plus b squared equals c squared. Or in our case, we went ahead and solved for like the c value, which is r. So r equals the square root of y squared plus x squared. Or you can reverse that, r equals the square root of x squared plus y squared. It's all the same. All right, so 13. So first thing it says sketch the standard position. Okay? So we remember that standard position starts where? And the positive side. And I'm going to count this by 2s. So that way I can get all my information in. Because I got to go out to -8, 0. Again, for you guys, this will be all multiple choice graph. So it's not like you'll actually have to generate your own graph. All right, so we need our terminal ray to go through -8, 0. So -8, 0 would be right here. Which direction did that rotate? Clockwise or counterclockwise? Counterclockwise. That's the standard position of this. Which represents which picture? A. Okay? So, now, let's start thinking about how this works. So we've got our point. The thing that we're missing is the radius. So we just talked about how to find the radius. R equals the square root of x squared plus y squared, or y squared plus x squared. It's all the same. Plug in your values and to get your radius. That's all you got to do. You know what x is, you know what y is. Nothing crazy here. So what is negative 8 squared? And it's always positive. What's 0 squared? And what is 64 plus 0? And what's the square root of 64? So you now know what r is. Okay? And now we can start finding all of 6 of our trig functions. How do we make sine when we're not on the unit circle? Y over r. How do we make cosine? X over r. How do I make tangent? Y over x. It's still the same. Okay? So if we can find these 3, then we can easily get the other ones because all we have to do is flip them. Reciprocal. So, y over r. What was our y value? What was our r value? So that gives us 0. What was our x value? What was our y value? Or sorry, r value, which was 8. And that gives us? And what is our y value? What is our x value? And that gives us? So there you go. Now we know the original 3, so we could easily get everybody else. What is the value of cosecant? It's going to be r over y, which gives us undefined, because that's going to put the 0 of sine in the denominator. What is the value of secant theta? You got it, r over x, which just will give us -1. Again, the reciprocal of -1 is still -1. And then last but not least, cotangent theta. X over y, which is undefined, because you take tangent, you do the reciprocal of it. Again, that puts the 0 in the denominator, so it is undefined. Perfect. Okay? Any questions over that? See? Easy peasy. You guys got this. 14, we're going to do it again. And again, it says, give us a sketch of the function. No, it doesn't. I don't know why they gave us a graph. So we'll just keep the graph there. It doesn't matter. But here it says, we've got tangent. And we know that theta lies in quadrant 4. Okay. Remember, how is tangent made? This is y over x, right? How are points in quadrant 4 made? What kind of x, what kind of y? A positive x and a negative y. So that tells you how tangent is really broken down. So who does that negative go with in the 8/15? It really goes with the 8. So we know that we really are dealing with the point 15, comma, -8. So now that we got that information, that's good. What's the other piece of information we need? We need the radius. We got to figure that guy out. So again, now that we know the point, we can figure out the radius real quick. Square root of x squared plus y squared. So we've got 15 squared plus -8 squared. So 15 squared gives us 225 plus -8 squared, 64. Square root of 289, which is a nice number of 17. You got it. If it didn't come out nice, you would work with the radical, as is. So, now that we know everybody, all we start doing is figuring out all the pieces of information. How do we find sine? Y over r. So what's the y value? -8. What's over 17? Perfect. There you go. How do we find cosine? X over R. 15 over 17. Perfect. How do we find, well, tangent we already know. Tangent we already know, so we know it's negative 8 over 15. So to get everybody else, do the reciprocals. Just like everything else we've done. So what is cosecant going to be? Okay. Negative 17 over 8. What is secant going to be? 17 over 15, because it's the reciprocal of cosine. And what is cotangent going to be? There you go. Any questions about getting those 6 trig functions? Okay. All right, so that takes us through 9-5. Okay? So that was just 13 and 14 that were 9-5. Now we are jumping into 9-6. And so the next couple questions, I believe, all the way up to number 23. So from here to 23 are all 9-6. And that means 24 and 25 are 9-7. Okay? So it wants to know these trig functions, all 6 of them, where the base is who? Where's our base angle? A. So I'll put a little star there. So let's label who is who from here. Remember, 9-6 was all about SOHCAHTOA. Okay? So who is 16 according to the base angle A? Adjacent. Perfect. Who is 63 according to star? It's the opposite. Fantastic. And certainly last but not least, that means this is the hypotenuse. So remember that word I just said a second ago? What was that again? SOHCAHTOA. Remember, this is the basic information for the 3 trig functions. So tells you about sine. Ka tells you about cosine. Toa tells you about tangent. So how do we make sine of A? Opposite over hypotenuse. That's what the O and the H mean. Opposite over hypotenuse. So what is the opposite? What is the hypotenuse? And of course, always with all these fractions, I haven't mentioned it before, but just always keep mentioning it. Make sure that you always reduce. Always reduce those fractions if they can. All right, cosine, how do we make it? Adjacent over hypotenuse. That's what the A and the H mean in Ka. Adjacent over hypotenuse. So what's the adjacent? What's the hypotenuse? Perfect. Okay. Tangent. Tangent A. How do we make it? Opposite over the adjacent. That's what the O and the A stand for. So what is opposite? What is the adjacent? There we go. Now that we have these 3 basic trig functions, it's easy to get the other ones because all you got to do is flip them. So, what is the answer for cosecant? 65 over 63, because it is the reciprocal of sine. I about wrote the wrong number. 65 over 63. What about secant? 65 over 16, because it is the reciprocal of cosine. What about cotangent? 16 over what? 63, because it is the reciprocal of tangent. All right. Moving on. So 16. So it says find the exact value express for the following expression, tangent 3 pi over 4. Okay? So remember in class we talked about this. I said that I would provide this table for you. I don't know about other trig teachers, but I'm going to provide this one. So in quadrant 1, this is the reference angle. Okay? Remember that when we talked about degrees in here, that it's between 0 and 90 degrees. And if we were in radians, it's between 0 and pi over 2. Or in other words, remember when I talked about it in class, I ignore the pi and think of it as a fraction. So it's between 0 and a half. When we're in quadrant 2, because that's quadrant 2 right there. How do you find the reference angle? All right, so 180 minus the angle. Or if we are in radians, you'll take pi minus the angle. Okay? And again, remember these are all about our angles that are from 90 degrees to 180 degrees. Or if we're in radians, pi over 2 to pi. Or again, remember, since I ignore the pi, I think about it as it's from a half to 1. Quadrant 3. How do we find the reference angle? The angle minus 180 degrees, or if we're in radians, subtract pi from it. Okay? And remember that these are from 180 degrees to 270 degrees, or if we're in radians, pi to 3 pi over 2. And again, as a decimal form of that, I ignore the pi, and it's from 1 to 1.5, or 1.5, or 3 over 3 halves. All the same. And then last but not least, quadrant 4. How do we find the reference angle? (360 degrees minus the angle, or if we're in radians, 2 pi minus your angle. And again, these are all from 270 degrees to 360 degrees. Or in radians, 3 pi halves to 2 pi. Which again, ignoring the pi, that's from 3 halves, which is 1.5, 1.5 to 2. So remember I said I'm going to give you that chart. I don't know what other teachers will do, but that's an important chart to know. So here we want to find the actual number for tangent 3 pi over 4. Also remember on your test, I'm going to give you the first quadrant. Angles 0 through 90, all the trig function answers, exact. So, if we can find the reference angle for this, then we're going to know what the answer is to this. So the first thing is, we need to figure out what quadrant we're in. We are in quadrant 2, because if you look at 3/4, ignore the pi, 3/4, that's 0.75. 0.75 is between a half and 1. So we know that this guy's in quadrant 2, which also tells us the sign of our value. Because remember, we have that nice little mnemonic device. All students take calculus. So remember that the all meant that quadrant 1, everybody was positive. Students, or S, meant in quadrant 2, sine and cosecant were positive. T, take, was for quadrant 3, which means what? Tangent and cotangent. And then calculus was quadrant 4, cosine and secant are positive. So since we are in quadrant 2 and we're tangent, is it going to be positive or negative? It's going to be negative, because in quadrant 2, only sines and cosecant are positive. So we know our answer has to be negative. No matter what, the answer is going to be negative. So now we figure out the reference angle. Because once we know the reference angle, whatever tangent of that reference angle is going to be the same answer for this guy, just negative. So how do I get the reference angle for 3 pi over 4 since we're in quadrant 2? You said that we'll take pi minus that angle. So what is pi minus 3 pi over 4? Pi over 4. So our answer is whatever tangent pi over 4 is, and it will be negative. So you'll have your little chart to look at, and you'll go and you'll figure out tangent pi over 4 is what? It's 1, but in our case, it will be a negative 1. Okay? Tangent of pi over 4 is a positive 1 when you look at the chart, but in our case, it will end up being a negative 1 because of the sign of being in quadrant 2. Yes, Anthony?
Shouldn't it be 2 pi over 4?
2 pi over 4? Well, remember to get this, you got to think about getting your common denominator. That would be 4 over 4.
Oh.
And 4 minus 3 is 1. Okay? Careful on that. All right. A lot of the next questions are going to be using this kind of little table that I've given you guys. Okay? Because remember, on this test, I want to make sure that you guys understand what reference angles do for you, and also you're going to be testing yourselves on those sign values. All students take calculus. All right, number 17. So we're doing the same thing again. Express cosecant of 2 pi over 3. So 2 pi over 3, first thing, let's figure out what quadrant it is. It's going to be in the second quadrant again, because 2 divided by 3 is 0.6 repeating, and that is between 0.5 and 1, which is quadrant 2. So that means in quadrant 2, who is positive? Sine and cosecant. So this answer will be positive or negative. In the end, this answer has to remain positive. Okay? So what we need to do now is figure out the reference angle. What's the formula to figure out this reference angle? Pi minus the 2 pi over 3. And what does that give us? Pi over 3. Definitely. So our answer will be positive, and whatever cosecant pi over 3 is. So you go to your chart, you look up cosecant pi over 3, and what do you get? 2 radical 3 over 3, and it stays positive because in quadrant 2, sine and cosecants are positive. Okay? Cofunction. It wants to know who is the cofunction for tangent 25. Well, who is the cofunction for tangent? Cotangent. You got it. Now, how do you get the angle for this cotangent? Yeah, you take 90 degrees minus your angle. Or if we're in radians, it would be pi halves minus your angle. Because remember, this is like going in our triangle. It's like we're doing SOHCAHTOA from the other angle. So cotangent of what angle? – 65 degrees. That's the cofunction they want. Because if you take 90 minus 25, you get the 65. Okay? So just remember that tangent and cotangent are cofunctions of each other. Who is the cofunction for sine? Cosine. Who is the cofunction for secant? Cosecant. Okay? And it's because you're going to the opposite angle, which changes your opposites and your adjacents. All right, number 19. What's the reference angle? Well, we've been talking about reference angles. So first things first, we got to figure out what quadrant we're in. Okay? So 11 pi over 9. 11 pi over 9. That's 1.2. So what quadrant is that? That's in quadrant 3 because 1.2 is between 1 and 1.5, which is quadrant 3. So we know that we're in quadrant 3. What is the formula for finding the reference angle in quadrant 3? Reverse that. The angle minus pi. So basically you're taking 11/9 and subtracting 1 from it. And what do you get? 2 pi over 9. And that's all they want. They just want the reference angle. 2 pi over 9. Okay? Number 20. Again, it says find the reference angle. But what's the problem right away? It's negative. Okay, we can't find the reference angle just yet. We need to do what to this first? Add 2 pi. We got to get that least positive coterminal angle first. We want to be between 0 and 360. So you need to take negative pi over 6 and add 2 pi to it. What do you get? 11 pi over 6. Good. So that's the least positive coterminal angle. And then from here, now we can figure out the reference angle. In order to do that, again, we got to know what quadrant are we in. You're in the 4th quadrant because 11 divided by 6 is basically 1.83 repeating. So 1.8 is definitely between 2 and 1.5, which is quadrant 4. And what is the formula for the reference angle in quadrant 4? 2 pi minus your angle, which is 11 pi over 6, which gives us what? Pi over 6. There's the reference angle. Almost done. Number 21. So, wants to find the 6 trig functions. So again, this is going to be a lot about reference angles and the quadrants and things like that. So we have 1,110 degrees, and we want to find the 6 trig functions for that. So what's the first thing we're going to have to do? Subtract 3. Yep, you got it. Till you get that least positive coterminal angle. We got to keep subtracting 360 until we get there. So what is the least positive coterminal angle for 1,110? 30 degrees. What quadrant is that in? 1, right? What's the reference angle for that? That's exactly what it is. We don't have to do anything special on this. Okay? And so since we're in quadrant 1, we know all the signs have to be what? Positive. So all we really have to do is look up what are all the answers for sine 30, cosine 30, tangent 30, cotangent 30, secant 30, cosecant 30, and just leave those answers alone because you're in quadrant 1. So what is sine 30, which is really sine 1,110 degrees? 1/2, 1 over 2. What is cosine 30? Radical 3 over 2. Tangent? Cosecant. With authority. Secant. And cotangent. There it is. You basically just had to look up whatever happened at sine, or whatever happened at 30 degrees. All right. Everyone good? Jumping over to number 22. All right. So we're doing the same thing again, but this time we're in radians instead of degrees. So what do we got to do first? Yeah, get it to a positive. Get that least positive coterminal angle again. So we got to take negative 5 pi over 4 and add 2 pi to it till we get there. So what is the least positive? 3 pi over 4. So we're looking at this angle. Okay? Now we got to figure out what quadrant that's in. It is in quadrant 2. I believe we've done 3 pi over 4 earlier in this packet. It is in quadrant 2, which I believe we also found the reference angle for that one as well too. Because in order to do that, we take pi minus 3 pi over 4, which gives us pi over 4. So all these answers are going to be related to whatever happens at pi over 4. All these answers are going to be related to whatever happens at pi over 4. Speaking of which, since we are in quadrant 2, that means we got to be worried about signs. In quadrant 2, what do we know about our trig functions? Sine and cosecant are the only positive. Good, Jasmanian. So that means cosine is negative, tangent is negative, secant is negative, cotangent has to be a negative answer. All those are negative. So all we got to do now is just figure out our trig functions at pi over 4. So what is sine at pi over 4? Radical 2 over 2. What is cosine at pi over 4? Negative radical 2 over 2. What is tangent at pi over 4? Negative 1. So you could look up the rest, or you could do reciprocals. I would just keep looking up the rest. There's, instead of trying to do reciprocals and things like that. So what is cosecant pi over 4? Radical 2. What is secant pi over 4? Negative radical 2. Negative Egyptian sign right there. Negative radical 2. And what is cotangent? Negative 1 as well. There you go. That's it. Okay. Number 23, which will end everything from 9.6. This one is purely the calculator. Purely going into that calculator and kick me out of the answer. The problem with this is we don't have a button for secant. So what would you push in order to get secant in there? Yeah, so you go to your calculator and you'll put 1 over cosine of this angle. 37 degrees, 42 minutes. Where are the symbols for degrees and minutes at? Second and apse, because you need to go under angle, and they're the top 2 pieces. Also, what do you need to check on this? Well, rounding is good. And make sure that your calculator is in degrees. Check the mode. Look and make sure that it is in degrees. Okay? So, when you go into your calculator and you type in what you got right here, what do you get for the answer? Because the directions say round to 8 decimal places. Look at that fine print. Make sure you look at the fine print. Okay? There you go. The other thing that you could have done, if you didn't want to work in minutes, you could have turned that back into the decimal for degrees. Take 42 degrees divided by 60, and you actually end up with 37.7 degrees. So you could have also done that in there. Your call. All right, 24, 25. These are all coming from 9.7. This is all about demolishing right triangles. That's what this guy was about. So the first thing is they want you to figure out angle M. So based off of what we know, how can I figure out angle M? subtract 90 from the 57.1, right? 90 degrees minus 57.1 degrees. What do you get? 32.9 degrees. Perfect. There's that piece. Now, to get N and P, what are we going to use? SOHCAHTOA. Use SOHCAHTOA. So everything, remember as I told you in class, I always base it off of the information that's given. Now granted, 32.9 degrees isn't an exact number, but again, I always tell you guys in class, be careful of that because there might be some times where that number might be rounded. So always go with based off of what they are giving you. Okay? So based off of the 57.1 degree, what is side N? Not, yeah, there you go, the opposite. I was hoping you wouldn't give me the answer. I wanted to actually know if it was adjacent, opposite, or hypotenuse. So good, yes, it's the opposite. What is side P? Hypotenuse. And last but not least, that means the 121 has to be the adjacent. So now we can start figuring out which trig functions to run. Because remember, I also told you in class that when you do SOHCAHTOA on this, there will be one trig function that just makes no sense because there are too many unknowns. So if I want to look for the side N, what trig function would we use? TOA. So in other words, tangent. So you want to find side N, we're going to run tangent 57.1 equal to what over what? Opposite over 121 or N over 121. And then remember, how did I tell you to solve this in class? Yep. Do that little quick cross multiplying here. So basically your answer is whatever 121 times tangent 57.1 degrees is, which you said was what? 187. And again, good rounding on that one because the directions say round to the nearest integer. So N is definitely 187. And in our case, if there was no label, it would be meters. Okay? How would we find side P? Cosine. Because you're dealing with adjacent and the hypotenuse. And that's cosine, that's ka. So, cosine 57.1 degrees equals what over what? 121 over P. And now in class, remember what I tell you you can do here. Yeah. Take these two pieces right there and switch them, and that will tell you the answer. Because it will be P equals 121 over cosine 57.1 degrees. And so rounding to the nearest integer, what does P equal? 223 is correct. Meters, of course, if there was no label there. Okay? Demolishing right triangles. Little SOHCAHTOA. Little adding, subtracting. And last but not least, kind of another demolish a right triangle, but you're only going to be looking for one piece. Again, on this one, I would draw a picture because everything's going to be related to a right triangle, and you need to know who your opposite, adjacent, and hypotenuse are. So, it says you are headed towards a plateau. So, whee, plateau. Okay? Here I am on my journey. So it says the plateau is 48 meters high. So that's this distance that's right here. 48 meters. It says if the angle of elevation to the top of the plateau is 10 degrees. So remember, angle of elevation means that you're looking over at this guy. And it's the looking up here that happens. So that is 10 degrees. That's the angle of elevation. It wants to know how far are you from the base of the plateau. So you're trying to find the adjacent. Who is the 48? The opposite. So we're going to use tangent to figure this out. Tangent 10 degrees is equal to what over what? Whatever you want to name it. X, P, just smiley face, whatever you want. So how do we solve this? Yeah, swap those two guys around. So x is equal to whatever 48 divided by tangent 10 degrees is. And I believe it says round to 2 decimal places. 272.22, I think it's meters. Meters. But of course it gives you the label there anyway. So that's it. That's what your test is going to be like. All we're going to basically do is change the numbers. What's your question? 24. On your screen, it says what angle you're looking at, but here it says color. So how do you know which one you're looking at? Yeah, it shows you that N is the angle that you do have. So this is the angle that you do have, which is N, the 57.1. So you always go based on that one? I would go based on the one that they actually give me, not the one that we actually solved for. Okay? Just in case that this angle that we solved for, like angle M, just in case this guy is a rounded answer. Even though, yes, we know it's exact, we could have worked with it, but just in case this guy's a rounded answer, I'd always go with the one that they gave us because we know that that's what they want. Okay? Any other questions? All right. Let's